Today we are solving logarithmic equations. You guys are going to be able to use the properties that we talked about Monday as well as last week to solve these logarithmic equations, okay? And then we're actually going to use it to relook at some certain exponential equations as well. So, it's pretty simple, straightforward. If you open up that first flap, you'll see I pretty much give you some steps to solving logarithmic equations, okay? The first step, well, you can have, two different situations. You can have it where you have a log on one side of the equal sign, or you can have a situation where you have a log on both sides, okay? So we're going to look at, it's going to be one of these two situations. When you have a log on only one side of your equal sign, there's 4 steps. The first thing you want to do is you want to isolate the log. What does isolate mean?
Make it by itself.
Make it alone.
Get it alone. Make it by itself, okay? So you want to get the log by itself on one side of that equal sign, okay? And, or, it just kind of depends on what you're given, apply properties to condense the log. So depending on what you have, you might just have to isolate the log, or you might have to apply your product property, your quotient property, so then that way you can actually start, solving. So the next thing after you've isolated the log is you want to rewrite it in exponential form. Don't give me the big eyes. You know how to convert from logarithmic form to exponential form. You just did it and you do now. Okay? So that's the second step. After you've done that, then you just need to solve from there. Okay? You just need to solve from there. And you guys know how to solve an exponential equation. We've done that. We did that before we started logs. The one thing that you definitely have to do with the logarithmic equation is you have to what the solutions?
Find.
Nope. Solving is where you find them. Once you find them, you need to check your solutions, okay? You've got to make sure you check your solutions because you cannot take the log of a negative number. That's why you have to check your solutions. You should be writing that down. You cannot take the log of a negative number. So if you solve this logarithmic equation, you get an answer, plug it back in. Because when you plug it back in, if it ends up giving you log of a negative number, you know it's a no solution because you cannot take the log of a negative number. Okay?
Wait, are we going to start using our calculators to solve?
For some of these, yes.
What, Ms. Anderson?
Yes.
When you touch the log button, what actually is it doing?
Okay, you missed this because you came in late on Monday. The log button on your calculator, that's a log with a base of 10. So the only time that you can actually figure out what the log of a number is if it's written like this: log base 10 of 3 or just log of 3. That's what the calculator does.
So what is log?
Okay. Huh?
What is log?
What is log? Okay, now that I didn't answer on Monday. A logarithmic function is the undoing of an exponential. Do you know how, like, when you have a problem that's 3x equals 6, don't you divide by 3 to get x by itself? Well, that's the opposite to solve for that variable. So if you have an exponential equation, the log is what helps you undo it to solve. And vice versa. All right, we're gonna look at some examples of this, okay? Like these two, C and D, okay? These are examples of where you have a log on one side, C and D, not A and B, C and D. You have a log on the left side, you don't have a log on the right side. Now, isolate the log. That's the first step, okay? If there are numbers in the front of the log, or if there's anything being added to the log, you want to get rid of those. That's what it means to isolate. Do we have anything like that? No, because that stuff that's in the parentheses is attached to the log, okay? And we only have one log, so we're good to go. Step 2 says to what?
Rewrite.
Rewrite. And this is part of the first one. We want to rewrite this. Now, To rewrite this in exponential form, we definitely need to know the base of this logarithm. What's the base of this logarithm?
10.
10. So when we rewrite it in exponential form, it's going to be what?
10 to the second power is equal to 12x plus 16.
Yes, that 12x plus 16, all of that is going to go on the right side of the equal sign. What's step 3?
Says
Solve.
Solve them, okay? What's 10 squared?
Like I mentioned yeah.
How do I solve for x?
Subtract 16.
Divide by 12.
What's 100 minus 16?
84.
Then I need to divide by 12. What's 84 divided by 12?
7.
What's the last step?
Check.
Check, okay? You check, you always go back to your original. When you multiply 12 by 7 and add 16, does that give you a positive number or a negative number?
Positive.
Positive. So really, truly, when you go back to check, you're really looking just to see if you're taking the log of a negative number. Since we're not taking the log of a negative number, we're good to go. Okay?
What? Okay, so if we do take a log of a negative number, then we know we got it wrong.
No. So you know that the answer you came up with is not actually an extra, it's an extraneous solution.
Okay.
So then if that was the only solution you got, there's no solution.
So it is possible to get a negative number, it would just not be a solution.
It is possible to get a negative number as a solution, but when you plug it back in, if that expression is a log of a negative, it's no solution.
Can you repeat the steps to check? You just plug it in.
You just plug it in, and I mean we could do this. 12 times 7 is 84, plus 16 is 100. Log 100 of 10 of 100 is 2. It equals 2. And we can go all the way.
I just thought that said R, and I was like, wait, what's R? Is
Definitely not.
this new variable?
This one, ln is a log, okay? It's a certain type of log. It's a natural log that goes with what exponential function? I talked about it on Monday.
1 point.
Not e squared, just e, okay? You'll need that when you're going to rewrite this in
Yeah, it was like 2 point something.
So, with this one, remember, go through your steps. The first step says to isolate the log and or apply properties. Is the log by itself here?
No.
No. What is there?
3.
That's a 3.
Oh, it's an ln.
Yes, ln. So that's a 3. So how do I get rid of that 3 times ln?
You divide.
I gotta move it. I gotta divide it. So you divide it to both sides. What's 6 divided by 3?
2.
So right now I have the ln of 9x plus 10 equals 2. No need to apply any properties here because it's just one log. Okay? Step 2.
Rewrite.
Rewrite in exponential form. Now, I just asked this, but what's the base?
No.
No, for natural log,
Would be E.
it's going to be e. Okay? The base of any natural logarithm is going to be e. E and natural log go together. So it's going to be e as your base. It's still going to be raised to the second power, and it's going to equal 9x plus 10. If you want, just so you can have maybe that visual there, if you want to write an e, that's fine. There's nothing wrong with that. If it'll help you with the whole process.
So, you don't do anything to D with the square. You can't. It's E squared. You can't go any further. Is there a number for E?
Yes, it's 2.71728 and keeps going after that. Okay? How do I solve for x?
You just subtract 10.
So I'm going to subtract 10. So that's e to the second minus 10 equals 9x.
You divide 9.
And you divide by 9.
Wait.
So that e squared minus 10 divided by 9, that's your answer. It is a decimal answer once you type it into your calculator.
So,
And then, of course, you're going to
does
round
this
from
one?
there. The 9 doesn't. Yeah.
So for the test, we're gonna have to like
On the test, what I'll probably.
and solve.
Yeah, you're going to have to put in your
Does this
calculator
matter-
and solve.
Do negatives matter for this? Like,
Yes, it still applies here. Whatever number you get here, when you plug it back in, you cannot have the natural log of a negative number either.
Is there an E on your calculator?
There is an E on your calculator. What I want you guys to do is go ahead and grab your calculator, and we're going to type this into our calculator. To solve these types of problems where E is involved, okay, you're going to have to work backwards. You really are going to have to work backwards, okay? You do need to take care of the E to the second power first. So what you do is you type in 2. You got to type 2, the exponent. You press the second button, and then you press the LN button, which is 3 buttons to the right. You should get a number that's 7.389. Like with this calculator, you got to work backwards. So you have to do the exponent and then second ln to do E, okay? So now you just got to do the rest. You subtract 10 and divide by 9. So x is equal to a negative 0.290. The next ones, E and F. Okay, this is another example of where you have a log on one side, but the difference is that you got 2 logs on one side, which means we're probably going to have to do what to this?
Combine like terms.
Condense it, compress it, bring it together, apply the properties. When you see a plus sign, that means you have to do what? Multiply. So this becomes log x plus 21 times x. X plus 21 times x becomes what? What do I do to that on the inside? So we have to condense it. This is still step 1. Okay? We had to apply the properties here to condense it. Now it looks similar to C and D. Step 2. Rewrite it. What's the base here? So it's going to be 10 to the equals. What's 10 squared? Who gets the gold star for today? How do I solve a problem like this? Subtract the 100, because this is a good old quadratic that you have to factor. A couple of y'all get the star, y'all. Y'all was right on it. From the subtracting of the 100 to the quadratic to the factoring, yes. I feel like y'all know when I say it's a good old, you know what comes next. Okay? So, when I make my x, what number goes on the top? Very good. Negative 100 on the bottom. 21.
25 4.
You look for 2 numbers that multiply to give you negative 100, add together to give you 21. So the 4 has to be the negative. All right, let's slow down a little bit. I feel like we're going kind of fast. I want to make sure everyone's still up with me. Okay. This turns into x plus 25 and x minus 4. What do I do from here? So x plus 25 equals 0. X minus 4 equal to 0. Okay. So we get 2 solutions here. We got to do step 4 for sure. Plug it in. When I plug in negative 25, what's negative 25 plus 21? Can I take the log of a negative 4? So we know this cannot be a solution. You cannot take the log of a negative number. Let's double check 4 real quick. 4 plus 21. We're good there. Log of 4. That's positive. So my only answer here is 4. Negative 25 is an extraneous solution. Okay? I'm so glad so many of y'all remembered how to factor. Yay! Okay. Huh? Oh, those are for the different types. So we're good to those. You're reaching. You're reaching. Uh-huh. All right, and the last one where we have a log on one side, okay? We're doing all the ones where we have a log on one side to make sure you guys have a good handle on them, okay? What do I need to do here? Subtraction means division. So this is going to be log base 4 of 5 over 2x equals 1. We have condensed it. The log is isolated. Now we go to step 2, which says to rewrite in exponential form. So this basically is 4 equals 5 over 2x. How do I solve for x? I need to get that x out of the denominator, so I'm going to multiply both sides by 2x. What's 2x times 4x? 8x equals 5. No, when you're solving in situations like this, you want to get rid of your denominator. So when you multiply both sides by 2x, you're eliminating the 2x altogether. Divide by 8, and x equals 5 over 8. When I plug in 5 over 8, is that going to give me a negative log anywhere? A positive times a positive is a, and this doesn't have an x, so we're good. It's 5 over 8. That is how you solve a logarithmic equation where you have a log on one side. Okay? When you have a log on both sides, it's actually even easier. Okay? It's even easier. It's still 4 steps, but it's even easier, okay? When you have a log on both sides, you either have to condense or expand if necessary. More than likely, you're just going to be condensing. It's very rare where you're going to expand. In this class, I'm not going to have you expand. It's only going to be condensed. Then you have to set the two arguments equal to each other. Then solve for the variable and check the solutions, okay? So really and truly, if you have a log on the left and a log on the right, the logs go away and you just set the pieces equal to each other. The same way we did it when it was like an exponential, right? The bases were the same. We dropped the bases and just set the exponents equal to each other. Let's look at A and B now. I have a log on the left, a log on the right. So we just dropped the log part and we just set the arguments, which is 2x plus 1 and 3x equal to each other. Simple as that. Then you solve. How do I solve? And then you always got to make sure, especially when you're solving a logarithmic equation, that you check your solution. When I plug 1 in, so it's still positive. So then we're good. Okay? What about on B? Drop the logs, and you drop the bases too. Okay? You drop the log and the base. You just need the argument, which is x minus 6 and 2x.
Wait, will you ever get like one of these with the ones on both sides where you get different bases?
No. If you do, then that's probably a typo on my part. Okay? Trey.
Sorry, that's
No. That's okay. You're asking for a repeat. Yes, for a repeat. Trey basically said, "Will we ever get one where you have a log like with different bases on both sides?" And I said, "No. If you do, that's probably a typing error on my part." Okay. Yeah, and that's why you're able to just cancel them out because it's the same log on both sides. Oh, that's something different. X equals what? Negative 6. When I plug it back in, what's negative 6 minus negative 6? Negative 12. Can I have that? Can I take the log of a negative 12? So this is not a solution. It's extraneous, which means this is a no solution type problem. You cannot take the log of a negative number. So there's no value for x that you can plug in where you're going to get them equal to each other. That's how you solve a logarithmic equation. Questions? Oh, I was going to say, wait. Let's look at this. You'll need your calculator for this, okay? You use logs to help you solve exponential functions that don't have like bases, okay? When we're doing the exponential part of this unit, all the bases, you could rewrite them so that they were the same. When they're not the same, you have to apply logs, okay? But this one's only 3 steps. First thing you want to do, what was the first step when you were solving a logarithmic equation? What did you do? Isolate. Same concept applies here. You need to isolate the exponential expression. If you're like, I still don't understand what that means, get the base by itself. Nothing else around it. Get the base by itself. Then you're going to take the log, or you're going to take the ln of both sides. You're not going to do both. It's going to be one or the other. Okay? Specifically, if the base is an e, the only thing you can take is the ln. Ln and e go together always. Okay? But if it's just a number, you can do the log. And then lastly, solve for the variable. You don't have to check anything here because the domain of exponential function is negative infinity to infinity. The value is going to work. Okay? So, G, isolate the exponential expression. Is the base part by itself? There's a minus 1 there. How do I get rid of that minus 1? You bring it over by adding. So I have 4x equals 17. And now the exponential expression, in other words, the base is by itself. Now we need to take the log of both sides. That literally means you're going to write log 4 to the x equals log 17. That's what it means to take the log of both sides. Okay. But I'm telling you, but it's not hard though. Okay, the reason why we want to take the log of the both sides is because we got to take that x out of the exponent. And by having a log here, we can apply the power property that says the exponent can go where? It goes in front of the log. So then this becomes x times log of 4 equals log of 17. How do you solve for x? Divide by log of 4. So this becomes log 17 divided by log of 4. And that's what we type into our calculator. Okay? Now, Sunny and Thomas, y'all just type yours in exactly how you see it. Log 17 divided by log 4. Get your answer. Us with these oh so wonderful calculators. Everybody got it? Are you ready? No. You got to go backwards. Okay? So, no. You got to start with the 17. 17's on top. So you go 17. No second here. Just log. So go 17 log. Everyone should have a 1.23 number. Then divide it by 4 log. And then you got to click the equal sign.
And you get
2.04 is x. Okay? No need to check here because the value we get is going to work. So just to repeat, when you type it into these good old TI-30XAs, you got to do 17 log divided 4 log enter. If you're lucky like these two, you just type it in normally. Okay? You could be. All right. Let's look at this one. Okay. Step 1, isolate the log, which is already isolated. Step 2, I need to take the ln of both sides. Here I have to do the ln because it's an e. So this becomes ln e x plus 1 equals ln 3. Okay? Well, not yet. I have an exponent. What happens to that exponent? It gets moved to the front, that entire expression. So this is really x plus 1 ln e equals ln 3. Now let me tell you how nice ln and e are together as a pair. They're opposites of each other. They basically undo each other. So if you have an ln and an e together, they cancel out. Anytime you have ln e together, they cancel out. So then you really are just left with x plus 1 equals ln of 3. How do I solve for x? So then x equals ln 3 minus 1, and that's what we type into our calculator. No. Just regular, it's a regular ln. If you want just ln, it's just the button. So you go 3 ln minus 1. ln 3 minus 1, yeah? Yep. That's an excellent question. If you notice, all these decimals that we've rounded have been rounded to 3 significant figures. Have I talked about 3 significant figures in this class? Okay. I'm going to ask you to round these to 3 significant figures. How do you round to 3 significant figures? You start with your first non-zero number, which was 9 in this case. And then you count from there. 1, 2, 3. And then you stop there. You start from your first non-zero number. That's why I went all the way to the 6 in this problem. That's why I went all the way to the 4 here, because this is 1, 2, 3. 3 significant figures. Okay? All right.